Hello everyone, I am Harshita Jain and this is my last video of the series Data Science. In this video, we will learn about uh, association rule mining with Python, a step-by-step guide. So, association rule mining is a technique used to discover relationships between items in a data set. For instance, in a market basket analysis, it identify products that are frequently bound together. There are key concepts like support, confidence, lift. Python library MLX stand. So the MLX stand library provides efficient implementations of various data mining algorithms, including association rule mining. So we install the library. Step first, install the library using pip install ml extend. Then for the necessary libraries, libraries and packages like a priori association rule, a priori and association rules, and pandas are speedy. Then load the dataset. Um, then processes the dataset. On hot encoding, convert the categorical data into numerical format using one hot encoding. Transaction encoding, convert the data frame into a list of transactions where each transaction is a list of items. Then find frequent item sets. So use the a priori function to find the frequent item sets based on a minimum support threshold. Like frequent item sets, this is the code. Then generate association rule. This is our code to generate association rule. Then analyze the results. So explore the general rules focusing on matrices like support, confidence, and lift. You then sort the rules based on these matrices to identify the most interesting relationships. Then this is our example. In this example, we import the necessary data packages like pandas and a priori and association rules. Then we load the data set. Sorry, we provide a data set. Then we encode the data. Then find the frequent item sets. Then generate association rules, and then finally print the rules. Additional consideration like minimum supported confidence, matrix selection, visualization. By following these steps and leveraging the MLX stand library, you can effectively mine association rules from your data set and uncover valuable insights. The next topic is understanding confidence difference criteria. So the confidence difference criteria is a statistical method used to compare the means of two populations. It involves calculating the confidence intervals for the means of each population and determining if these interval overlap. If the interval overlap, we cannot conclude that there is a significant difference between the means. Applying confidence interval criteria in Python. So this is the step-by-step process, like importing necessary libraries like NumPy and stats. Then defining sample data, then confidence interval. We in this code we define a confidence interval like calculate the confidence interval for the means of the two samples, then calculate confidence interval for sample 1, then calculate the confidence interval for sample 2, then compare confidence interval. So visually inspect the confidence interval to see if they overlap. If they do, we cannot conclude a significant difference between the means. Then fifth is statistical test, which is optional. For more formal statistical test, you can use t-test to compare the means, and this is the implementation to perform the t-test. Then this is a key consideration like sample size, population distribution, and equal variances. So the next topic is understanding confidence intervals. Like a confidence interval is a range of values that is likely to contain the true population parameter with a certain level of confidence. For example, a 95% of confidence interval means that if we were to repeat the sampling process many times, 95% of the interval would contain the true population parameter using the confidence intervals to compare population. Calculate the confidence interval for each population. In this, we have to like we have to first calculate the confidence interval for each population, and then calculate the confidence interval for each population. Here, this is a Python implementation of association rule, and this is we put the NumPy, Skippy stats, then sample data of two populations, then perform the t-test. If p-values is less than the significance level like 0.05, or we reject the null hypothesis and conclude that the means are significantly different. And this is our output, like t-test equals to this and p-value is this. That's all for the today video. Thank you.